welcome to the first of the acid-base titrations for the Leaving Cert syllabus. In this titration, we will use a standard solution of sodium carbonate to standardise a solution of hydrochloric acid of unknown concentration. We will use methyl orange as the indicator. I will run through this in detail, this titration, so that you can follow this in future titrations throughout the course. There are two important pieces of apparatus used in a titration. The first being the burette. Now, it is possible you could mistake this for some kind of a fencing sword or something, but in fact it's not. It is a device for measuring the quantity of acid that's added during the titration, and it is in the upright, in a retort in the upright position like this. The second important piece of apparatus is the pipette. Now this looks like a blow dart or something, but no, that's not what it's for. It's actually a accurate measuring device for the base that goes into the conical flask during the titration. These are two very important pieces of apparatus not to be messed with. I'll start the titration by rinsing all the glassware we need, first with deionized water. I'm going to take about 100 ml of my sodium carbonate standard solution and pour it into a clean, dry beaker, which I've already labelled sodium carbonate. The reason for this is so that I don't contaminate my stock solution, standard solution of sodium carbonate. I will do the same with the hydrochloric acid solution. Pour 100 ml roughly into this beaker. I'm going to fill my pipette using a pipette filler. We're not going to do it like they did in the old days, sucking up through the pipette. So I attach my pipette filler onto the pipette, and I take my sodium carbonate solution from the clean beaker that I just filled. I fill the pipette like so, all the way up to the graduation mark, so that the bottom of the meniscus is sitting perfectly on the graduation mark at eye level. I'm going to make sure there are no bubbles in the pipette, and then I'm going to transfer to the conical flask, like so. The conical flask has been rinsed out with deionized water prior to this transfer. At the end, I touch the pipette off the conical just to remove the final drops. There will always be one drop left, which is accounted for within the graduation. Using a small funnel, fill the burette with hydrochloric acid solution. It's important to remove the funnel from the burette when full, as it may introduce an error into the readings if drops of liquid fall from the funnel once the titration has started. Open the tap slowly and allow some of the acid solution to run through into a waste beaker, filling the tap and the space below the tap. Ensure any bubbles or airlocks are removed. Once I've filled the burette, I release this volume down to close to the 0 point mark by opening up the tap. I want the bottom of the meniscus to sit on the 0 point graduation mark. At this point we add a few drops of methyl orange to the basic solution in the conical flask. Just enough that I see a colour in the solution. I'm going to add hydrochloric acid solution from the burette to the conical flask until I see a colour change. I do this while swirling the conical flask because it's important that all the acid mixes with the base as it goes into the conical flask. So swirling all the time and adding in a slow dropwise manner until the point where the solution remains pink. And now, how you found the end point of the titration. We've completed the first rough titration, and I'm going to take the measurement to see exactly what volume of acid was required. So we'll now repeat the titration a number of times until we get at least 2 titers with values within 0.1 of a mil of each other.